Good morning, good morning, good morning. I hope everyone is happy and healthy and doing fabulously. Today is a lesson on graphing radical functions. So what does it mean when we're graphing radical functions? Well, we have all of these examples of functions that we're going to consider. And this is simply about the rules for shifting. So we've talked about parent functions. And we've talked about where the numbers need to be in order to address those. We're going to continue that main idea with radicals. So the first thing we need to know is that there are two main shapes of radicals. So there are two shapes. For radical functions. Now, this is because if it is an even radical, so if it's square root, if it's to the fourth root, if it's to the sixth root, you can't have a negative number inside that radical because it's an imaginary number. We all know that the square root of a negative number doesn't exist. So the square root of -4 is technically I times the square root of 4, and square root of 4 is 2, so this is 2i, a positive and negative 2i. But remember that this I is imaginary. So when we're thinking about the graphs, if the numbers are even, so if the radical is even, for the most part, it starts at 0, 0, and it goes like this. And that makes sense because as we just discussed, everything negative is imaginary. So if it's even, that's going to make sense. Now we can have negatives if the radical is odd. So if the radical is odd, so we could do the cube root of -1 because that is going to be -1. Because -1 times -1 times -1, this is a positive 1 times a -1, which is a -1. We can absolutely get both positive and negative. So if the radical is odd, meaning if the root is 3, 5, 7, 9, then the graph is going to look a little bit different because it's going to have both positive and negative values. So again, it's going to go through the origin and it's going to look the same for the first half, but then it's going to do the same kind of flip. So this is a square root radical, this is a cube root radical. So you can notice you can grab this position. That's the vertex. And based on the equation, you can know how the vertex is going to change. You can also tell what's going to happen to some other parts of this equation. So let's look at one of the equations. So looking at this, let me erase. Okay. If the number is under the radical right next to the x, so right here, that is going to change. It's going to move the vertex. It's going to move the vertex right or left. And what you have to keep in mind is that it's always going to be the opposite direction of what you think. So a negative number moves it to the right, and a positive number moves it to the left. So negative moves it to the right, and a positive moves it left. So this is going to move it to the left 3. Then, if the number is outside the radical, that moves the vertex up and down. Now this one, it's the same. So positive moves it up and negative moves it down. So this +1 is going to move it up 1. So if I were to sketch this graph, it is a square root function. It is going to move it left 3, 1, 2, 3. It is going to move it up 1. So the new vertex is going to be approximately there. Oh no, it's not going to move it left 3, it's going to move it right 3. Because it is a negative. Whew. Good thing I was double checking my work. So it is going to move it to the right 3, 1, 2, 3, and up 1. And then the graph of the line is going to be the same. So you just have to recognize how it's going to move, and then the graph is the same. So let's do another one. Okay, actually there's no more examples that give that same thing. That's all right. I can do another one down here. So if the function of x is the square root of x plus 2 minus 5, because the 2 is underneath the radical, and it's right next to the x, and the x-axis goes right or left, we know this is going to go right or left. Because it's opposite with the x, it is going to move it left 2. Now, because the 5 is outside of the radical, it is going to move it up or down. And outside the radical, it's the same. It matches. So it is going to move it down 5. Oh. So I left 2, 1, 2. Down 5. 1, 2, 3, 4, 5. And then the graph is the same. That's it. Now, what about these other numbers? Okay. So, what happens if there's a 2 in front of it? Well, this is going to change the fatness or steepness of our graph. Let me say that again. A number in front, a coefficient, is going to change the fatness or steepness of the graph. Fatness or steepness, how fat or how skinny it is, changes the width of the graph, changes the shape of the graph. And it's usually going to make it steeper or flatter. So if the normal one is this, a number greater than 1 is going to move it closer, flatter, less of a curve. So numbers greater than 1 so this is the normal, this is the parent function. If it's greater than 1, it's going to make it flatter. If it's greater than 1, it's going to make it flatter. And if it's less than 1, it's going to make it steeper. Yes, and that's kind of counterintuitive, but that's the way it is. So it changes the shape of the graph. So this one, it's going to change the shape of it. It's going to make it flatter, and it's going to move it up 1. Because this moves it up 1. Here, the 1/2 is going to make it steeper. And then the -3 moves the vertex down 3. What about negatives? Negatives, flip it across the x-axis. So if originally this graph looked like this, the new graph would flip it across. So instead, it's going to look like this, not this one. It just flips it across the x-axis. Then you're going to move it down 2. Okay, so this 2 makes it flatter. And this 3 is going to move it up 3. Okay, this 4, it's inside the radical. And remember, these are going to be opposites. So normally I would think -4 is to the left, but instead that's going to move it right 4. And then this is going to move it down 2. This is going to move it across the x-axis. And then this is going to move it left 5. This is less than 1. So it's going to make it steeper. This is -1, so it's going to move it down 1. So I want you to be able to look at a radical function and describe what is going to happen to its graph and which number is telling you to do so. Hopefully you should be able to do that. And I will talk with you soon.